In Germany in 1895, physical chemist Wilhelm Ostwald raised a beaker at the University of Leipzig and declared to the world, "Matter is only a container for energy." The declaration of this leader of energy-only theory was like a stone thrown into a pond, stirring up tremors throughout the scientific community. When his opponent, Boltzmann, wrote the formula for molecular motion on the blackboard, no one thought that the debate would continue throughout the history of modern physics, much less that the answer would emerge in such an amazing way in today's world of humming quantum computers. At the beginning of the 20th century, Einstein pressed the pause button on the debate with the equation E equals mc squared. The mushroom cloud rising from Hiroshima seemed to declare the triumph of energy-only theory. Matter could indeed be transformed into astounding amounts of energy. In the circular tunnel of the Large Hadron Collider in Geneva, scientists discovered a deeper truth. When positive and negative electrons collide and annihilate at the speed of light, the energy does not return to nothingness, but is transformed into a brilliant shower of particles. This reminds people of the Big Bang model, revealing the picture of creation. 13.8 billion years ago, the entire universe was huddled in a singularity of pure energy smaller than an atom. The most shocking discovery of modern cosmology is the origin of the universe from nothing, and the theory of inflation proposed by Gus in 1980 depicts such a scene. In the instant of 10 to the minus 36 seconds, the quantum fluctuation in the vacuum was dramatically stretched, and 10 to the power of 80 elementary particles appeared in the ocean of energy out of nowhere. This completely overturns the traditional view of matter. The universe, a precision instrument, is actually activated from pure energy. Even more startling evidence came from dark energy observations, when two teams of researchers simultaneously discovered in 1998 that a mysterious energy was accelerating the expansion of the universe. This energy, which accounts for 68% of the total mass energy of the universe, is neither matter nor radiation, and resembles the pure energy field predicted by Ostwald. When we look up at the starry sky, the galaxies we see are just bubbles floating on the ocean of energy, like icebergs floating out of the water at the tip. But if you declare that energy-only theory is completely correct, you will fall into the same misunderstanding as Boltzmann in 2012. The discovery of the Higgs boson revealed the truth. Energy needs matter as a carrier to realize self-expression. In quantum field theory, elementary particles are essentially vibrational modes of an energy field. Just as the vibration of a guitar string produces the notes, the vibration of the Higgs field gives the particles their mass. This process of transformation plays out continuously in the stellar furnace. When 4 hydrogen nuclei fuse into helium at the core of the Sun, 0.7% of the mass is converted into energy, but the reverse process is just as important. In the magnetic storms of the Crab Nebula, high-energy photons spontaneously generate pairs of positive and negative electrons. The interchanges between energy and matter are like the breathing of the universe, maintaining the ecological balance that has existed from creation to the present day. In 1982, physicist John Wheeler wrote it from bit on the blackboard, lifting the third curtain on the nature of the universe. When quantum entanglement experiments proved that information does not disappear, it was suddenly realized that the transformation of energy must pay the cost of information. The black hole information paradox debate exposed the startling truth: even when matter is swallowed up by a black hole, the information it contains is still encoded in energy in the form of Hawking radiation. Living systems take this relationship to the extreme. Each base pair of the DNA double helix stores 6 bits of information, and 15 of the 20 watts of power that keep the human brain running are used for information processing. From the symmetrical patterns of snowflake crystals to the fluctuating curves of stock market quotes, the universe seems to be engaged in a continuous carving of information, and energy is both the carving knife and the stone. At the intersection of these discoveries, a bold hypothesis is taking shape. The universe may indeed have some kind of purpose, the evolution of energy into higher forms. This is not a theological teleology, but a view of evolution based on the second law of thermodynamics. When energy flows from a homogeneous, thermally silent state to an organized structure, it needs matter as a carrier and information as a navigation chart. The conversion of hydrogen to iron by stars is essentially a ladder of energy escalation. The energy released by nuclear fusion in the core drives the synthesis of more complex elements in the outer layers. In living systems, ATP molecules flow from cell to cell like energy currency, and each hydrolysis is accompanied by an exchange of information. Even the evolution of human civilization can be seen as a leap in the efficiency of energy conversion. From burning wood to nuclear fusion, the amount of information created per unit of energy shows an exponential increase. This hypothesis gives new meaning to human civilization. When radio telescopes convert electromagnetic waves into digital signals, and when colliders convert electrical energy into Higgs particles, we may be fulfilling the mission entrusted to us by the universe, to convert raw energy into comprehensible information. Just as coral worms build coral reefs out of calcium carbonate, and humans build digital worlds out of silicon-based chips, both are essentially leaps in energy form. But this evolution comes at a cost. According to Randall's principle, for every 1 bit of information erased, KTLN 2 joules of heat are necessarily generated. The exponential growth of human civilization's information processing is accelerating energy consumption. From the melting of glaciers to the extinction of species, these crises may be the evolutionary threshold set by the universe. The only way to enter the next level of civilization is to break through the ultimate efficiency of energy use. Back to the original question, was Oswald wrong? Modern science gives a contradictory answer. He was both right and wrong. Energy is indeed the source of the universe, but just as seeds need soil to grow, energy needs the cooperation of matter and information to bloom. This trinity of relationships is similar to the ancient Chinese philosophy of Tao begets one, one begets two, two begets three, and three begets all things. As to whether the universe has a purpose, we may never be able to prove it, but what is certain is that in the 13.8 billion years of evolutionary epoch, energy has always been pursuing a more efficient transformation path. From quarks, gluons, and plasma to DNA molecules, from stellar fusion to neural network discharges, every link in this evolutionary chain speaks to the same conjecture. Cosmic energy is controlling everything through us. When someday humans create controlled nuclear fusion or decipher the nature of consciousness, we may hear the first loud bang of the universe since its birth, one that resonates with the upgrading of civilization.